So I really appreciate your work for setting up this environment and making this presentation happen. So I'm happy with that. Perfect. So thank you very much. Unfortunately, I was not able to join the conference in person, so I will try to do it remotely, and hopefully all the technical issues will fade away as we were speaking. So I'm Jure Michalek. I'm working for Espressif Systems, and one of the boards that you will have on the workshop is also displayed here. And Espressif System is the company behind ESP8266, ESP32, and ESP32S series, which is based on Extensa Core. You may know it, but there is also the new series of chip beginning with the C and H. This one is with the RISC-V core, and those who will attend the workshop will work with this RISC-V cores. So that's kind of new series of the chips that are available. And Espressif as a company is really appreciating the open source movement. So whatever we are doing, we are publishing it as open source. So please check out github.com/Espressif. You can find there many examples, tool, even the main ESP IDE framework is there. So yes, if you have any question or any issue with the software, yeah, raise the issue there, and we are working using this GitHub as open source tool for us, so we can help you to resolve some issues if you have with the chips. So and regarding the office in Czech Republic, so we are in Brno near main train station. So if you happen to travel through the Czech Republic, yes, stop by and ring a bell and say hello. We'll be happy to drink coffee or two with you. So we are there, not far away from main train station. Okay, so one thing that might be confusing for many people about the Espressif is that there are so many chips, so many flavors, different combinations, and we have this address products.espressif.com where you can find all the details, docs, documents, and some descriptions of the dev kit, and even the state of the chip, whether it's in mass production, whether it was phased out, and so on. And one important thing about the chip that you can choose for the project is, hey, that chip has like 12 years of guaranteed support. So if you release a chip, there's like 12 years that it will be supported, and you can verify the information here. Okay, so and let's talk about the Rust, because we are here about the Rust. And the question is, which operating system you can use with ESP chips and Rust? First of all, my team is focused on so-called no STD, also known as bare metal Rust. So it's pretty minimalistic. You got just the hull that our guys are preparing, and you are interacting immediately with the hardware. And it's pretty minimalistic. So there is like no overhead. And on the other hand, you have to do a lot of the stuff yourself. So you have to implement your own schedulers and stuff like that. So then another option is use the ESP IDF, which is the framework, and it's running on free RTOS. And this is known in the C world. So you can write a Rust application, so-called STD application, and use this kind of operating system underneath it. But let me mention also other operating system that you can work with Rust on ESP chips, and it's a Zephyr. And also NATX. So both operating systems you can create STD applications for and run, for example, isolated application in kind of sandbox on one core. So all of these operating systems are available. The choice is up to the designer what he will use for the software development. So, and the last but not least, we are also publishing SVD files to our chips, so you can find the mapping of registries online. It's available on the GitHub under SVD. So if you are very close to the hardware, you know what I'm talking about these SVD files. If you are like a little bit further, working just with operating system, you probably don't need it. So let me speak about the programming languages. So actively supported by Espressif team is the C and C++, since this is kind of majority and most common choice for programming embedded hardware. But thankfully, the Rust is getting bigger and greater attention also in embedded world, and it's good because with the C you spend a lot of time playing with libraries, trying to link them together. For Rust, you just run cargo and that's done. And our tool chains are working both with Extensa and RISC-V architecture. And we have some examples where you can compile the same project for the WebAssembly, desktop, and mobile. So Rust is good here, and we have a great community, ESPRS, a lot of contributions. So I have to say big thank you to all contributors and all hobbyists and professionals who are working with Rust and helping us to make Rust go-to choice for embedded development. Because yeah, the development with Rust and embedded, it's like way better feeling than just plain old C. Okay, so then another team is working also on Arduino. This is a very well-known maker choice, and yeah, it's pretty common in the makerspace. So, and some other languages just to mention here, because those languages can be integrated to some extent with Rust. For example, you can call cbindgen and call the other languages like Ada and Spark from Ferro Systems and Ada Core. Then also embedded Wizard, or even somebody was able to run a new Zig on ESP32. And if you are more into the virtual machine-based languages, there is CircuitPython, MicroPython, Toit. C# guys, hello, here is the Nano framework, Mongoose, Lua, but you got bigger VM here. And it's also a good option for prototyping this virtual machine-based systems. So what about the IDEs? First of all, probably the Rust community is using in many places VS Code, which is also Espressif extension. So you can get not only Rust support, but ESP IDE support there. And this is like go-to choice. We also provide Espressif IDE, which is more for C developers. Unfortunately, Eclipse, which is a foundation of this Espressif IDE, had the Rust plugin, but it was kind of discontinued. So not that a good choice for Rust. So VS Code is better here. And if you are a fan of JetBrains, then the C Lion is in very good shape, and you can use it together with normal Rust desktop development, also for embedded development. And some other IDEs that you can find is like Visual GDB or Embedded Wizard. So if you'd like to learn more about Rust language on ESP chips, we did 2 talks during our last developer conference. Scott Mabin, who is the founder of ESPRS organization, has a very nice talk about it. And then I did some talk at Rust Links in November. You can find the video on YouTube. And now let's move to Wokwi. Let's move to really cool stuff that we were not showcasing in other presentations, and I'm very happy to share with you also some updates that were done just last week. So that's really cool. So what is Wokwi? Wokwi is not Espressif project. Wokwi is a project of Uri Shaket, who is working with us. And we are very happy to cooperate with him on this project. It's kind of open source to some extent, and it's basically the simulator of ESP32, and not only ESP32, but also our other chips like S2, S3, C3, and C6. So let's see what we can find here. So if I go to wokwi.com/rust, you find this nice landing page. You can click the project, see it here. just hit the run button, and yeah, the simulation is running. You can see the board with the C3 connected here. You can see that something is going on. Here is the eyelid display, here is the console. So this is really cool because I can play with the code without having any installation of local machine. If you are first seeing this for the first time, let's mention how it operates underneath it. There is a build server, which is building the stuff for you. Here you got the editor where you can write the code. And this is really cool, I think. The diagram JSON basically describes what you see. So you can either drag and drop things, or you can describe it here in the JSON. So what we recommend is if you have kind of like your hardware layout and you'd like to share it with somebody else, you can use Wokwi to like describe the schematics. And this is really cool because you can not only replicate the source code, but also like physical layout and see it visually immediately here. Okay, so that's what we can find here. And we add here also the landing page for the Rust, so you can play with some examples. You may find that some examples are broken. Just let us know. We'll try to fix it as soon as possible because the Rust is moving very quickly. And sometimes it happens that the build engine is broken. Okay, so that's the Wokwi online embedded simulator. And if we end here, it's just like, yeah, that's nice. That's nice for beginners, for playing. But Wokwi has more than this. So let me share with you some really cool stuff. So first of all, behind the Wokwi, there is a community of people who are writing and playing with examples. So you can grab any example that you have. For example, let me select this clock, and I can edit and save the stuff here, and I can grab the URL and send it to anybody, and he will be able to continue with the work on the project, see the same stuff, which is like really cool. So I can share the examples there. And not only that, the community is also adding hardware to that, like the virtual hardware. So let me share with you this example that appeared this week. And this is really cool. This is e-paper module that somebody has written and connected to ESP32. Here you can see the Rust code. And if I hit the run, you can see the simulation is running. And yeah, the e-ink display, the simulated ink display is working. So pretty cool. But wait, there is more. So you can write your own display or whatever using so-called custom chips. This is kind of like C code or like Rust code project that you put on the GitHub and just link it to your project. So that's pretty nice. Okay, another really cool thing that was added recently was this thing. Let me hit the run button and hit the pause button. Oh, and this is nice. So you can see the state of pins and try to zoom it. Yeah, you can see it here. The state and the mode of the pins and the GPIOs. You can see, for example, here we got the out and it's on high. Here is out and low. Here is SPI2 with the MOSI. So you can see where the stuff should be connected. Yeah, so this is really nice. It can help you to navigate and see the state of the pins. So this is something what is not possible with the real hardware, but you can do it with the simulator. So let's continue with the stuff. Then another very useful feature is hidden behind F1 keystroke. So I will now hit the F1 and I will get this command palette, and I can type commands like download, and I can download compiled firmware here. So even without me having the hardware, I can even download the stuff which is running on this virtual simulated chip. So F1 and download the firmware. And not only that, you can even run a Wi-Fi packet capture, which can be very useful if you are trying to debug some Wi-Fi related stuff. So if you try to do Wireshark capture on ESP32, it's pretty like impossible, but with the simulator, it's easy. So you can run the simulation. I don't know, you need to debug MQTT for some reason. With the simulator, you can. So F1 is the hidden key that can give you access to like many features of Wokwi. Pretty cool. Let's go and see what is even more cooler, and that's Logic Analyzer. So if you try to connect Logic Analyzer in the real world, it's pretty tedious job, and the Logic Analyzer is not the cheapest thing in the world. But here you can get it for kind of free. You can just drag and drop and connect to some pins. I don't know, this one, this one, this one, and then run the simulation. And you can see it's collecting the samples. If I hit stop, I immediately got the file with the data that I can feed into analytical software and see what is going on. And so, for example, you can use pulse view. And here's an example of I2C communication. So very easy, even without me having a real hardware, I'm able to get what is going on with the I2C using just a Wokwi simulator without purchasing real hardware. Yeah, that's nice. And of course, somebody can replicate it. So that's also very good. If you are speaking with somebody who is like on remote location, working with the hardware, this is always also good. Okay, so let's move away from this web browser, because yeah, this is kind of nice, the web browser, but for the productivity, you need something more than just a web browser. And let's go to VS Code plugin. So, for example, let me go to Hello Rust code, and if I type just the start Wokwi simulator, I should get working stuff. And yeah, here we go. Immediately integrated into Visual Studio Code. I've got Hello World here, and it's working, the simulation. So this is also nice. And let me show even more features that you can have here. So let's start and create some ESP32 project, so that you can see that I'm not like making this stuff. Okay, cargo generate, and let's create a new project. Here I will answer that I don't want to use default values for template, so I can choose what I'm setting. So ESP32, you can see that the templates already support multiple things. And here I will say, okay, I want integration with VS Code, and I would like to have also integration with Wokwi. So let's go. Cargo build. And then the project will be built, and I will be able to work with this project locally. Okay, let's see that it's working relatively fast, so we don't spend here entire session just looking at the compilation. Okay, so let's go code. And now I would like to show something cool. And here we got a source code and some warnings. Go away warning. Let me hit here the breakpoint. Yes, that's good. And now I will start Wokwi simulator and wait for debugger. So, okay, the simulator is now running. And now I will go to the debug session. Here is the Wokwi GDB. I will hit run. And voila, voici. We are now at the breakpoint. So without having set up JTAG or any debugger hardware, I am able to see all the stuff in the Rust. I can see also registries at CPU, so you can see what is on CPU on each registry. You can see timers, timer group, and everything. And I can like step over and move to the next command. So this is pretty cool. So you can use Wokwi with debugger in the Visual Studio Code. And I think this is pretty amazing. So again, how I did it, I opened the project, I started a Wokwi simulator, which was waiting for debugger, and then I started debugging. You may ask how this magic is done. So basically, you can have your own Rust project already. You just need to add Wokwi toml file, which is pointing to ELF files, and then set a GDB port server. And then you have to have the diagram JSON, which is the same as we've seen in the web browser. And that's it. Basically, you can add this VS Code files, so the VS Code is able to provide you with some neat integration, and that's it. That's it. You are then able to debug ESP32, which normally is not possible to debug. Because you need for this chip JTAG, so you need to connect ESP-proc. With the newer chips, there is JTAG already integrated, so you can debug it immediately. So, but I'm showing you the debugger even without the hardware. Neat. Okay. So, and wait, there is more. You can even profile the stuff. So, and here you can see the example of Rust application running on ESP32 with the Wokwi simulator. Here you can see the Rust application, and you can with the simulator just profile the program on the web, and then you can hit this profiler Wokwi.com, upload the profiling file, and you will get the analysis and see where most of your application is spending time. And we already learned a lot of useful stuff from this. For example, that if you are logging using USB, it's eating a lot of CPU cycles. So it's also good to have this image, this picture, and know what's going on underneath. And but wait, there is more. You can use the Wokwi in CI. So here we are. Here is the Wokwi CI action project. It's relatively simple. You just throw it to your project with the GitHub workflow, and you just grab the token from Wokwi account page. You can put it here, and then you can say, hey, I expect that this project, my ESP32, is running and it's outputting some kind of text, for example, hello world, and if it fails, it should produce some kind of error. That's another use case of Wokwi. You can use it for the CI. And this thing was added just a month ago. So pretty new stuff. But wait, there is more. We are able to generate even the screenshot from simulated LCD running on simulated hardware, which you can find in one of my examples, a spooky maze game. This is the Rust bare metal implementation using embedded graphics, and here is the screenshot. So you can tell Wokwi, hey, grab the screen. So if you are doing something with LCDs, the Wokwi has this neat feature to do that, and it's pretty cool. So if you'd like to add your own peripherals, your own chips, it's possible to use so-called custom chips. So you can program and create your own hardware, which should talk, for example, to ESP32. Let me scroll down, and there are already some existing chips done, like Surgate, SPI chip, I2C, and timer chip, and so on. So Wokwi is pretty extensible, and community is contributing a lot here. So you can use it also for the Rust projects. And let me share with you some really cool news. That ESP32C6 is the module with the Wi-Fi 6 support that was announced and was finally released to market like not long time ago. Here on the screen, you can see one of the main features of Wi-Fi 6. So everybody who is concerned about the battery consumption should pay attention, because a lot of people are complaining, hey, ESP32, it's like burning 100 milliamps all the time we're connecting to Wi-Fi. Yeah, that's true. That's unfortunately the nature of Wi-Fi. But with C6, you can use the Wi-Fi 6 feature, which allows you to negotiate with access point some gaps. So you can say, the chip can say, hey, I'm turning all radios off and I will be alive in 1 second. So don't talk to me for that 1 second or even longer. So that's one cool feature of the C6. The second important feature of this chip and of several other chips that are already on the market is so-called low power core that is running on lower frequencies. And you can task this core to do some actions for you while the main core is sleeping, and you can go to some microamps here. So if you are concerned about energy a lot and you have very little energy, then low power core should be something for you. And that's not everything, because you can now simulate this core with the Wokwi. So this is like the addition from the last week. So you are not only able to simulate ESP32C6, which is RISC-V core, but also this low power core, which is again RISC-V, because RISC-V. So let me show you the simulation here. 32C6 low power code. And yeah, start Wokwi simulator. Okay, simulator running. And here is the breakout board custom chip. And you see that the main board is waiting for the signal on I2C just to like wake up when there is like too much light. So I will dial up the amount, and you see something is going on. The main core was woken up, and if I dial down, the low power core just shut down the main core, and this way you can save the energy. And now you can simulate it with Wokwi with this custom chip. So pretty amazing stuff. Okay, some final remarks where you can learn more about Rust and ESPs. We have this ESP-RS book. We are contributing there, communities contributing there and extending it. So feel free to create a pull request or anything if you like to improve it here. Then you can find also so-called STD training. So if you're not into the bare metal and you'd like to use more of the STD stuff, Ferrous Systems helped us to create a training material for the C3. So if the C3 is interesting for you, the training material is available for free. And we have to thank Ferrous System for that, and also community for helping us developing the material. And some of you might be interested in the async. And the good news is that Embassy is working with ESP. It's still work in progress. It's early, but some examples are already working, including Wi-Fi, the async Wi-Fi with Embassy. But the word of warning, it's like early stage, and yeah, expect some instabilities, but it's moving fast because the Rust community is amazing and helping a lot here. So, and regarding the board that I was showing in the beginning, we are also trying to contribute and pay a tribute to Rust. So there is this board. You can find it in the ESP-RS organization. It's available there. You can either purchase it or make your own copy using KiCad templates. They're available there. So feel free to hack and improve even this hardware design. And again, we open source even hardware design here, and we are very happy that the community suggested several improvements already. So we are like at the third iteration of this board, thanks to the community. So and this board is also available for attendees of the workshop. Okay. There are many more topics than we can cover, but we are probably running out of time. So check out also the Matter if you are into home automation. We have a very nice setup there, and our colleagues are working on Matter RS project, which is Rust Matter implementation, and it was officially contributed to official repo of Matter project. So, and if you'd like to learn more about what we did for the chips and so on, go to YouTube and search for Espressif Developer Conference 2022. There are many cool stuff that we published there. And we will be preparing new one in September. So you can book your seat at YouTube and see us there. And we will be at Embedded World 2024 in Nuremberg, Germany, very likely. And also we are in Brno, so if you are traveling across Czech Republic, stop by and please say hello. So that's all from my presentation that I have here. Okay, I lost the mic for some reason. So as far as I understood, there was the question about the Rust adoption. And also, so we are seeing growing interest in Rust adoption. For example, in the last Embedded World in Nuremberg, we were thinking that we will be there just like answering a few questions about the Rust, and in the end of the day, in the end of 4 days, we were just standing there, and people keep coming and asking about Rust. Hey, what about the Rust? How we can use it? We are interested in using Rust. So Rust adoption is growing there, and yeah, also other chip manufacturers are doing some works here. Sometimes it's only community. We decided to support the community and work together on that. So that's as far as I was able to understand the first part of question. I'm sorry, but probably the audio was lost. So that's only part that I understood. Yeah, I can barely hear it. So maybe one thing, we can write some questions, and I can send a response to Hazard's chat.
And we're just going to use the microphone on the laptop.
Yeah, okay. That's good.
Just talk. Try talking closer to the microphone.
Okay, so probably now you can hear me and see me.
Yes. Good to see you, Omar.
Yeah, good to see you too. So the second question, I guess, which is the technical part, is in regards to, let's say, strategy for development of Rust and ESP32. So in the sense that probably, like you mentioned, you're working on Embassy, but it seems like there's still some differences compared to other HALs where, you know, there's a dedicated Embassy HAL for like STM32s and Raspberry Pis. But for the Express, if it's sort of adding the executor on top of the existing HAL. So I don't know if you can comment a bit on that. It seems like there's a lot of focus around embedded HAL itself and having sort of these generic traits. But is there something beyond that that Espressif is planning?
Okay, cool. Thank you very much for that question. Let me explain the history, how we begin. So first of all, we started with something where the Rust was already working, and that was STD. So we took Rust STD, which is on top of ESP IDF. Then as the second step, we created this bare metal approach. And after like mastering these two approaches, we were able to reach the state with the tool chains and all the stuff that the embassy started to working there. Yes, the HALs are divergent a little bit, but we are trying to integrate them together. So in the end of the day, the async approach seems to be very desired because it's used on the desktops on servers. And we would like to see also this for embedded chips. And Scott and the rest of the team is really invested into this embassy idea. So yeah, we are getting there. We got the basics, and now we are getting there and making the support better. Also, the important part to mention here is that Espressif start launching new chips. You probably noticed that there is a C6, there is the H2, there will be P4 by the end of the year, and the team is working hard as a primary priority to get support for these new chips. So as the H2 becomes available, you should have the full hull for Rust STD and bare metal. And once this is working, the embassy should run on that thing. So, and this is kind of our approach that we have right now.
Perfect. Thank you.
Any other questions?
Okay, thank you very much for having me here. I will send you the slides so you can share it also with attendance of conference. Thank you very much and have a great conference. Bye-bye.